Today, I'm back at one of my favorite parks, Big Spring State Park, and I'm going to be trying out the half-square antenna. This is a simple wire antenna that has some very impressive features. 3.6 dBi of gain broadside and a fairly low takeoff angle. So this should be an excellent DX antenna. In this video, I'll be talking about the configuration of the antenna, going over some of the modeling, and then I'll set it up out here in the field and do some comparisons against a quarter wave vertical using the reverse beacon network, and then I'll try to log into a couple web SDRs and compare signal strengths of each antenna. And then finally I'll get on the air and try to make some contacts. The half-square antenna consists of two vertical sides that are a quarter wavelength long, and then a top section that's a half wavelength long. The antenna performs kind of like two-phase verticals, which is why you get a little bit of gain. It's a full wavelength antenna, so for 20 meters it'll be about 66 feet long, two 17-foot vertical sections and a 33-foot top section. So there are two ways to feed this antenna. You can feed it at the top corner. This will be current fed, and the impedance will be close to 50 ohms, so you don't need any kind of matching unit. It will be a monoband antenna. You'll also have to find a way to bring the coax away from the antenna a little bit before it slopes down to your radio. Or you can feed it at the bottom corner. This will be voltage fed, but the impedance will be quite high, so you need something like a 49-to-1. In fact, this is the same length of wire as like a 40-meter in-fed half wave, but you'll get all the harmonics. They'll be resonant on 40 meters, 20 meters, 15 meters, and 10 meters, but with some very interesting radiation patterns. You'll also need a small counterpoise for the small amount of return current. So let's look at the modeling for each configuration, and I'll show you how it looks on each band and compare it briefly to a quarter wave vertical. So let's take a look at the modeling very briefly. And to look at this, I'm going to be using a really neat website that I just found the other day. It's portableantennas.com, and I'll link it down in the description. This website is from Rob DM1CM. And it's actually just really a great website to look at different antennas, look at the modeling, and you really don't have to know a whole lot about modeling to take a look at this. So here is the half square that is current fed, which means fed up in the top corner here. So what you can do is you can kind of configure this half square. You can choose current fed, voltage fed, and it'll actually show you a model of it here. And you can actually move it around, which is pretty neat. And then you can come down here and basically look at the modeling for different bands. Like right now I have it on the principal band, which would be 20 meters. You can change the soil, a bunch of different features. So I ran this, and basically the max gain is 3.67 dBi. And as you can see from the plots here, it's broadside. You get a very wide beam width. And then as far as the elevation goes, the max gain is at 21 degrees. But what's real interesting about the half square is if you come down to 6 degrees. Most of your DX is going to be between, I believe, 5 degrees and 10 degrees off the horizon. So this is where if you really need to look at your gain figures if you want to get DX. So it's -1 dBi of gain. And I'll compare that to a quarter wave vertical here in a second. You can see why this antenna should be a better DX antenna. And then we have a 3D model here of the radiation pattern. So you can see it's a very wide beam width broadside to the antenna. So let's take a look at the voltage fed. This would be fed at the bottom corner with a 49-to-1. So I put 40 meters here because it's a 40-meter in-fed half wave. And of course you've got a small counterpoise here. So I left the settings as far as soil and everything the same. And it's very similar to the current fed version. 3.66 dBi of gain. Very similar radiation patterns. The takeoff angle is a little bit higher, 24 degrees over 21 degrees, but still looking very good at 6 degrees off the horizon, -1.2. So this would be fed at the bottom corner. Now let's compare that to a quarter wave vertical. Here I've got a quarter wave vertical pulled up on his website, and this would be with elevated radials, just like a lot of people run for parks in the air. Elevated radials because it's a much more efficient antenna. So if you look at the radiation pattern, of course it's going to be omnidirectional, but the gain is going to be max at 0.54. You know, in my understanding of a vertical, you know, you get these omnidirectional patterns, so it's shooting radiation in all directions, kind of like a floodlight. It may not be the brightest thing, but you're lighting up the whole room. Whereas like a directional antenna, you've got a lens on a flashlight and you're aiming the beam. It's kind of concentrating that power in one direction. But here's where it's really interesting if you compare the gain at a low takeoff angle. So at 6 degrees off the horizon, it's negative 4.3. So the half square should be a much better DX antenna if conditions cooperate. And lately they haven't really, but eventually we'll be out there one day when conditions are going to be good, and I think this would be a decent antenna to try out. So let's look at the modeling for the other bands on the half square if you're using a 49:1 and feeding it at the bottom corner. So on 40 meters, this is the same antenna that we just showed, and I just have the modeling run for 40 meters. You can see the gain figures are similar, but it's more of a omnidirectional antenna, but it's a very high angle of radiation that, you know, it's basically just going straight up like an invis type antenna. So this is not going to be a great DX antenna on 40 meters. But if you live in a highly populated area, this actually might be a really good antenna because you're going to get a lot of contacts, probably up to about 500-600 miles, I believe. So this might be a really good antenna if you're you know, along the East Coast or in the Northeast when you have a very high densely populated areas. On 15 meters is where things get kind of interesting. So you kind of get this clover leaf radiation pattern with pretty good gain, 3.67 dBi of gain, and a low takeoff angle. It's 21 degrees and 0.7 dBi at 6 degrees. So if 15 meters is open, this should be a really, really interesting antenna. As you can see here from the 3D model, it's not quite all broadside. You got a little knoll here, and it's kind of like I guess a clover leaf shape is what they call that, I believe. And then on 10 meters, it's kind of similar to 15 meters. You're going to get pretty good gain, 4.6 dBi of gain, and then fairly good. It's essentially negative 1 dBi of gain at 6 degrees off the horizon, and then max gain is at 21 degrees. So that looks pretty interesting. Of course, 10 meters hasn't been opening up this year yet. Hopefully soon. All right, so I'm going to try to deploy this half square antenna. Originally, I was planning on feeding it in the top corner. However, 15 meters is looking pretty decent lately. So I thought it'd be kind of fun to try this on a few different bands to see if we can't maybe possibly get some DX if conditions allow. So what I did is I measured out just a full length of wire around 66 feet. I cut a little bit long. And then about 17 feet up, I just put some heat shrink tubing, which made a little loop, and then I connected some paracord. And what that should do is allow me to support it between two masts. All right, so I have the half square deployed. I've got it supported on either end by 31-foot masts. And I have them a little bit spaced off the mast, mainly to get away from my truck. On this side right over here, I've got the feed point. So on one side, I've got my mast and this drive-on mast holder. My buddy N9JOE built this for me, and I love this thing. I can just drive on there and have a really nice support. But anyway, you can see that the mast goes up, And I have it spaced a little bit off. I'm not using the top couple sections of this mast because I don't want it to break. But over here you can see the one side of the vertical section coming down. And I have that just basically secured to the ground here with just a stake so it's not blowing everywhere. And then over here, so here's the feed point. I've got my 10 tennas, 49-to-1, and I'm feeding it on the bottom corner. I've got a choke right under that. And then this other wire is a counterpoise. And I've just got that bungeed to this little cedar tree here. There's probably a better way to secure that. And here's my POTA performer. I've got that set up, just a quarter wave with 2 elevated radials. This will be the reference antenna that we compare the half square to. All right, so I've got both antennas set up, and I've got my nano VNA hooked up to nano VNA saver. And I'm gonna go ahead and do some SWR sweeps on both antennas just to kind of see where we're at. So first, I'm just going to do a sweep across the half square from 7 megahertz all the way to 30 megahertz. And let's see what we've got. Okay, so as you can see here, we've got a nice dip on 40 meters, 20 meters, looks pretty good on 15 meters, and then of course looks great on 10 meters. So now I'm just going to do individual band sweeps. Let's start with 40 meters. And sweep that. You can see I'm looking pretty good on 40 meters. Let's see here let me move this over here. Okay, so we're 1.3 with impedance of 65 ohms at the bottom end of 40 meters. Let's look at 20 meters. And 20 meters is flat across the band. It's a little bit higher than I'd like, but you know, there's been a couple videos recently about SWR derangement syndrome, and I guess I'm guilty of that because I usually try to get the best SWR. But as you can see here, it's 1.4 at the bottom and 1.4 at the top, so flat across the band. Let's look at 15 meters. Didn't hit set here. So 15 meters looks great. It's 1.2. That's excellent. And then finally we'll look at 10 meters. So 10 meters looks great too. It's 1.2 at the bottom end of 10 meters. So let me just switch over to my quarter wave vertical on 20 meters just to show you what I've got there. Let's do a sweep there. Looks great. So the whip's fully extended. I could probably, if it was a little bit longer, it'd be great, but I mean, you can't complain about 1.1 SWR. So let me hook this to the radio and we'll do some on-the-air tests. All right, so I'm listening to a POTA station right now. And that's a half square, and then we'll go back to the other antenna here. So this is the quarter wave. So there's less noise. So this is the half square, and this is the quarter wave. Half square, quarter wave. So that's a quarter wave. This is a half square. So the half square seems to be a little bit quieter. So I'm going to go ahead and do an RBN test just on the quarter wave vertical, and then we'll do some KiwiSDR, then I'll do an RBN test on the half square. All right, so let's take a look at the RBN spots I got with both the quarter wave vertical and the half square. So right here we have the spots I got with the quarter wave vertical. I sent test and my call sign about 3 or 4 times over a few minutes. And so I got 6 total spots. The strongest one was in Southern California. The rest were fairly weak. And here are the RBN spots I got right after I called CQ when I started my activation, a few minutes after I sent the RBN spots on the quarter wave vertical. As you can see, in the Midwest up towards Chicago, I was fairly strong. So this Southern Tennessee, I was fairly strong. And then pretty decent up to the Northeast, as well as California, Arizona, and Southern Utah. Now this antenna, most of the radiation pattern is off the broadside and there are nulls off the ends. And so you kind of see that with the initial RBN spots. And the antenna was facing just slightly northeast, mostly east, a little bit north. And so that kind of matches up with the RBN spots. Now here are the RBN spots I got for the whole day on the half square. And as you can see, almost everything was broadside to the antenna. The antenna was kind of facing this direction. So the broadside was towards the northeast, and then we got a little bit towards the west. One weak RBN spot up towards the northwest, which makes sense. That's kind of off the end almost. And then one very weak one in Central America. So the RBN spots kind of match up with the radiation pattern of this antenna. All right, so I have KiwiSDR pulled up and I'm on the half square right now. I'm gonna go ahead and key the radio. This station's up near Chicago. So we're a little over S7. Between S6 and S7. And then here's the quarter wave. So it's actually a little stronger at this SWR. So let's try a different one here. Let's go a little further away. All right, this is near Boston. Let's see what we've got here. Okay, so here's the quarter wave. All right, we're S3 there. All right, I think they're about the same. Let's try at least one more here. Let's try one way up here in Canada. So I'm not seeing a huge difference. Did a few tests on the KiwiSDR, and so far, you know, it looks like the quarter wave is performing just as well, if not a little bit better than the half square, which is kind of interesting because the modeling on the half square looks a lot better. But I'm gonna go ahead and get on the air with the half square and see if we can't make some contacts using it. And it'll be kind of interesting. I'll switch back and forth between the two just to kind of see which stations are stronger and weaker with the antenna. And then here a little bit, I'm going to jump on 15 meters and see if I can't make some contacts. All right, I've got an open frequency and I'm going to go ahead and spot myself and call CQ. All right, so I just finished my activation. I ended up making quite a few contacts, but it was fairly slow compared to what I normally see out here. Conditions weren't great. In fact, I had a couple friends text me and say that they were having a hard time. So I think the antenna performed pretty well. I made 147 contacts in 3.5 hours. I took a few breaks in there, but overall it did really well. I tried to get on 15 meters, but I think I only made one contact. All the others were on 20 meters, except for I did make 4 contacts on 40 meters, which is pretty rare for me in the middle of the day. As far as the comparison between the quarter wave vertical, I tried to log into a few SDRs, and they were very similar. On a few of them that I checked, I was S9 or excuse me S7 on both antennas. At points the quarter wave actually was louder, just slightly louder. But overall, the half square did well. I don't know if it's worth the effort putting it up, but I think sometime I would like to try and feed it at the top corner to see if it's any better. But if conditions were that bad, I didn't really check on the solar weather. I know that the solar winds have been kind of high the last couple days, and the KP index was 4. I just checked it. So making over 100 contacts in those kind of conditions, I think it's pretty good. So anyway, if you give this antenna a shot, let me know how it works for you. Until then, 73.